This is going to be our flipped classroom on nuclear reactions / natural transmutation. So first, a quick definition. When an isotope, or an atom, if you will, is unstable, it gives off radiation. So what that literally means is the atom is so uneven, unbalanced, that it shakes itself apart and part of its insides from its nucleus come radiating out. So this means that a part of the nucleus of an atom will split off from the atom itself, and this is what we call radiation. It radiates out. So when this happens has to do with the amount of neutrons versus protons. There's a neutron to proton ratio that is stable, and if you're not at that number, it is unstable. But we're not going to get into that today. What I want to get into is what happens when an atom does this. What happens when an atom gives off radiation or transmutes. So as I said here, this can cause the atom to change or transmute into a completely new atom. Now, there are different types of nuclear radiation, or what we call natural transmutation. And the types of radiation, the things that are given off by the atom, can be found on table O of the reference table. So we're going to be talking about two things. Number one is the types of nuclear radiation, and then the effect of it, what happens after an atom gives off part of its nucleus, what happens to it. So first, let's look at table O of the reference table. I'm going to zoom in here. Oh, a little too much. So you can see on table O of the reference table, we have 6 different types of what we call radiation. But the ones I want to focus on today are these 3. Alpha particles, beta particles, and positrons. Now again, these all exist. They're all different types, and you can see their symbols and their notations. But I want to focus on these 3. So first, let's talk about alpha. Now, what exactly is an alpha particle? Well, if you look at the symbol notation for an alpha particle, it is He with a 2 on the bottom and a 4 on the top. What is He? Well, that's the symbol for helium. So an alpha particle is literally a helium nucleus. And let's confirm that, because if you look in the reference table, how many protons does helium have? Well, it has 2. That explains the 2 on the bottom. How many neutrons does an alpha particle have? It also has 2, because 2 plus 2 gives us the atomic mass of 4. So literally speaking, when an atom gives off an alpha particle or gives off alpha radiation, it's giving off a helium nucleus. Picture 2 protons and 2 neutrons that are in a small group, forced together and being thrust out of the atom, coming at you. Now, this type of radiation is dangerous, obviously, because any type of nuclear radiation is unsafe. But of all the types of radiation, this is the least dangerous because it is the heaviest. And the heavier the particle is, in this case 4, the slower it moves. You can actually absorb alpha radiation with just paper. So if you were to cover your body in Post-it notes, you, in theory, should be safe from alpha radiation. And again, here's the symbol for an alpha particle. It's the Greek letter A. Another type of radiation is called a beta particle. And if you notice, the symbol for beta particle is an E with a -1 on the bottom and a 0 on the top. That's the notation, or B- as the symbol. What exactly is a beta particle? Well, the E stands for electron. It's actually just an electron. Remember, electrons have no real mass and have a -1 charge. The difference between a beta particle and an electron is really just semantics. A beta particle is an electron that's being forced out of the atom really, really, really fast. So it's electron moving very quickly out of the atom. And that makes it extremely dangerous because it's so small. Beta particle radiation is really, really harmful. The only thing more harmful than beta is gamma radiation. You can see gamma radiation has no mass and no charge. It's just energy, which means there's no way to stop it. You have to just let it be absorbed by something else, like concrete or layers of lead. And the last type of radiation I want to talk about is called the positron. And positron radiation is the symbol B+. You can see it's almost the same as an electron. It's a 0, but this time it's over a positive one. So picture a positron as a positive electron. That's what it is. Now, let's talk about nuclear reactions. What are nuclear reactions? They are the reactions where you have a radioactive atom or radioisotope giving off some type of radiation, and then when it does that, it becomes a new atom. So in this example, I want to figure out what X is. In other words, what type of radiation is being given off here. To do this problem, you just treat it like two very short and simple math problems, where you have a number on the top and a number on the bottom for everything, and your goal is to figure out what those numbers are, and when you find these two numbers, you can figure out what X is. So treat the arrow like it was an equal sign, and then just do the math like this. 226 is equal to 222 plus what? Or what is 226 minus 222? And the answer you get is 4. Then let's do the same problem on the bottom. 88, which is the atomic number for radium, is equal to 86, which is the atomic number for radon, plus what? Or, in other words, 88 minus 86 equals what? And the answer is 2. And then once you get these two numbers, you go, well, then what is X? Well, there's only one radiation that has a 4 on the top and the 2 on the bottom, and that's the helium nucleus. So this is an alpha particle. So this radiation is showing the transmutation of radium into radon and then giving off alpha. Let's try another one of these. I have this radioisotope. It's thorium with an atomic mass of 234, so it's thorium-234. And I looked up its atomic number in the reference table. Its atomic number is 90. So then what exactly happens to thorium? Well, apparently it radiates into something, gives off some type of radiation, and then becomes Pa. So let's do the math again. 234 is equal to 234 plus what? Well, obviously, that's the same number, so the number on top is a 0. Now let's do the bottom number. 90 is equal to 91 plus what? In other words, what plus 91 would give me a 90? Well, the only number that would work there is a -1. So what radioactive radiation, what type of particle radiation has a 0 on the top and a -1 on the bottom? Let's see, that would be a beta particle. So this would be beta. Let's do one more of these. We have calcium-37. So calcium has different isotopes. This one happens to be radioactive. It becomes potassium-37. So again, doing the math, 37 is equal to 37 plus 0. Now let's do the bottom number. 20 is equal to 19 plus what? Well, that would be just a +1. What radiation has a 0 on top and a 1 on the bottom? Well, looking at my list, positron is 0 over 1, so this must be a positron. Or you can give it this symbol, B+. Now, another type of way to show nuclear reactions is not trying to solve for the radiation, but instead trying to solve for what the atom is going to become, what it's going to turn into. I'm going to show you a complex problem like this one here. I have carbon-14. You may remember from other sciences, carbon-14 is definitely a radioactive isotope, and it has the atomic number 6. All carbons do. And now I have two blanks. I'm not telling you what type of radiation, nor am I telling you what it's turning into. So I have two unknowns, which you cannot solve a problem with two unknowns. You at least need to know the type of radiation so you can figure out what it's going to become. Fortunately, there is a reference table you can use, not table O, but table N. And table N lists a bunch of selected radioisotopes, including carbon-14. It mentions things like its half-life, which we're not doing right now. Its decay mode, however, is this symbol here, a B-. Now, what exactly is a B-? Well, we can go back to table O and look that up. Oh yeah, that's right. That's a beta particle. That's a 0 over -1. So that means that the radiation here is a beta, 0 over -1. Now let's solve for what carbon-14 is going to turn into. Again, just do some simple math here. 14 is equal to some number plus 0. Well, obviously that number's got to be a 14, right? 14 plus 0 equals 14. Now let's do the bottom number. 6 is equal to some number plus a negative 1, or 6 is equal to x minus 1. What is this number going to be? It's a 7. Let's check. 7 minus 1 equals 6. So now that I have the two numbers here, what is this new atom that carbon has turned into? I don't really care about the top number because the top number just is the mass, and as we know, there are different isotopes with different masses. But the bottom number is very distinctive. Only one atom has the atomic number 7. Let's look it up and figure out which one that is. And in my reference table, atomic number 7 means nitrogen. So what does carbon-14 turn into? It turns into nitrogen-14. The symbol right there. All right, and that is our lesson on nuclear reactions and natural transmutation.